In our previous videos, we learned about dynamic or current electricity. It is the form of electricity generated by the flow of electrons. And we have seen that the movement of electrons possible only through conductors because only conductors have large number of free electrons. So, if we take a conductor, for example, a copper wire, and connect its two ends to the terminals of a lamp, do you think that the lamp will glow? No, right? Even though copper wire has large number of free electrons. Why it is so? Let us find out. As we know, the conductors like copper, aluminum or any have large number of free electrons, but they are moving in random direction inside the conductor. Like what will happen if a turbine placed in a pond? It can't rotate. But if we place it in a river, it will start rotating because in river the water flowing in one direction exerts a force on turbine and hence it rotates. Similarly, in order to turn on the lamp, electrons should flow in one direction through the lamp. For that, there must have a pushing force to establish electrons flow in one direction. So in circuits, a device is necessary that can push electrons to flow in one direction. Battery is one of such device we are very familiar with. How a battery creates electrons flow in circuits. To understand that, we must understand a term electrical potential difference. First, let us make it clear what is potential difference with some examples. Consider that we have two beakers filled with water and both are connected together by a pipe. In a way, the water can flow between beakers. When both beakers are at ground level, the water level in both beakers are same and there is no water flow in between. In this case, what we can do to create water flow from one beaker to another? The simplest way is just lift one beaker up. Then we can see water flowing from top beaker to lower one. How this happened? Simply we can say this happened because of the height difference. But according to science, this happened because of the potential energy difference between the beakers. Potential energy is the energy stored in an object when it is in rest. When height increases, its potential energy also increases. An object at higher potential will fall down to lower potential by itself. Like if we throw a ball up, it will fall down by itself. All this happening because of the Earth's gravitational force. The same theory is applied in our water pipeline system, where the water tank is always placed at heights, means the water is at higher potential energy, which helps the water to flow down by itself with high pressure. When the tank is at lower heights, the potential energy is comparatively low and which results in low pressure water flow. In short, in all these applications, we are implementing a theory that an object at higher potential will fall down to lower potential by itself. For that, we are creating a potential difference between source and out to facilitate the flow. Same way, the battery also creates an electrical potential difference in circuits. In a way, the battery has two regions, positive and negative. The negative side is filled with abundant of electrons, hence it is higher in electron potential when compared with positive region where no electron present. So, the electrons will start flowing from negative side to positive side when they connected together by a conductor. Here, the battery acts as a pump in water pipeline system. The pump maintains water flow with same pressure by recirculating water from ground to tank. Similarly, battery maintains continuous flow of electrons from negative side to positive side. Hence, if battery is dead, the entire circuit is dead. Here, in all related to electricity, the potential difference between any two points or the electrical potential difference is referred by a term voltage and is measured in the unit of volt. The name volt is derived from the name of Italian physicist Alessandro Volta, who invented possibly the first chemical battery. Volt is simply represented by letter V. If you check any batteries or mobile chargers, the manufacturers must have mentioned its voltage values like 1.5 volt, 5 volt, 9 volt, etc. It indicates the maximum voltage or potential difference that a battery can create in a circuit. As voltage value increases, the electrons flow in the circuit increases. Like if water tank capacity increases, the water flows with more pressure. But if it exceeds a certain limit, it could damage the pipe or its assemblies. Similarly, the voltage source also should be used according to the capacity of circuits. Otherwise, it could damage the circuit or devices used. That's why every electronic device manufacturers mention and recommends its maximum voltage that can be connected to it. The voltage between any two points can be measured using a device called voltmeter. The two probes of voltmeter can be connected to the 2 points where voltage to be checked. Make sure that positive probe has connected to positive terminal and negative probe has connected to negative terminal. If a fault battery is checked, you may see 0 volt or lesser volt than its specification. So, we have seen what is voltage and how it is measured. As voltage, there is another important measure in circuits called current. Its meaning is same as what we have seen with term current electricity. Current is nothing but the flow of electrons. More clearly, current is the amount of electrons passing through a point or cross-section area per second. It is measured in the unit of ampere. The ampere is named after French physicist and mathematician Henri-Marie Ampere. It is denoted by letter A. 1 ampere of current means 6.25 into 10 power 18 electrons passing a point per second. Current is usually not measured in terms of number of electrons. It is measured in unit of ampere. You must have seen batteries or chargers mentioned its current values like 1000 mAh, 2000 mAh like that. Here mAh, that is milliamps per hour, means the maximum current that battery can deliver for 1 hour. In other words, if a circuit consumes 2000 milliamps in 1 hour, this battery will work for maximum 1 hour. In other case, if a circuit consumes only 1000 milliamps per hour, this battery will work for maximum 2 hours. The device named ammeter is used to measure current in circuits. Ammeter must be connected in between the terminals because it is measuring the flow of electrons, like flow meter connected in pipelines. And the polarity must be matching. We already seen that the current increases with voltage. There is another important factor that affects flow of electrons called resistance. Resistance is nothing but the measure of opposition to electron flow in circuits. It is measured in the unit of ohm, represented by the symbol omega. It's like valve in a water line. When valve is closed, no water flows. Flow increases as valve opens. Here, valve acts as a resistor to the water flow. Similarly, there are many factors that affect flow of electrons, like non-conductive impurity particles present in wire and thickness of wire, etc. We know if size of pipeline reduced, water flow also reduces. Similarly, thin wire will reduce current flow in circuit. Like voltmeter and ammeter, the resistance of any object or device can be measured using a device called ohm meter. We already learned that only conductors allow electrons to pass through. Hence, conductors have negligible or zero resistance. Meanwhile, insulators do not allow electrons to pass through because insulators have high resistance to electrons flow. In place of these electromechanical measuring instruments, digital voltmeter, ammeter, ohmmeter are available today, which provides more precise reading. The most commonly used measuring instrument today is multimeter, which can be used as voltmeter, ammeter, ohmmeter, and many by simply changing its mode, which is very useful for beginners in electronics. All this we will learn in more detail in upcoming tutorials. So, in this tutorial, we have learned three important terms of electricity: voltage, current, and resistance. Voltage is the potential difference between 2 points in an electric field, which cause electrons to flow in a circuit. Unit is volt and represented by letter V. Current is the rate of flow of electrons in a conductor. In other words, the number of electrons passing through a point or cross-section area per second. Unit is ampere and represented by letter A. Resistance is the measure of opposition to electrons flow. Unit is ohm and represented by symbol omega. Make sure that you are good with above concepts. because it is necessary to have strong understanding about these three concepts to move further. Thank you.